All right, first things first. We've had our first big weekend and obviously Monday off. And just want to remind you of things that have been going on. So I went ahead and logged into my Hawk system. And I did push back 2.1a, which is on that left-hand, right-hand limit. So that's officially, that lesson is due today. What's coming up due this weekend is you're going to have quiz number 2, which is on 2.1a and 2.1b. And then on Sunday, the lesson is due on 2.1b limits, 2.2a rate of change, and 2.2b rate of change, which is where I'll be doing this one today as well. So just give an idea, don't fall behind on this stuff. Procrastination kills. So keep up with your lessons and stuff like that. We've already had due 1.5, 1.6a, 1.6b, and 1.8, and of course, Saturday was your first quiz and stuff like that. So, and remember, with quizzes, I always give you 2 times to take it, and the computer will take your best grade. So just to let you know. All right. Oh, hold on just a second. All right. So as we were saying, just keep an eye on what's due today and what's due to. Usually I have this stuff due on the weekend, but occasionally, if I don't quite finish something or other, I'll push it back to the middle of the week. So I'll always make sure you got a few days to get your homework done after I finish something or other. And I may do the same thing on section 2.2b, but just pay attention to that stuff. All right. Last time we were working on section 2.1b. Question? I think I did. Time is moving. All right. So, thank you. What we were talking about last time was 2.1b, which is limits. So let's talk about the concept of limits. Now, we're not talking about one-sided limits, going from the left or from right and doing the little T-bar type thing here. We're talking about what we expect you guys to do with limits. And I'll show you guys when to do what, why. All right. First rule of limits. Here's the idea. You're taking the limit as x approaches a of f of x equals L. This is a full limit. There's no little minus or plus behind this guy. This is not a one-sided limit. Now, for this to exist, here's the idea. This guy exists if and only if the limit as x approaches a from below of f of x is equal to the limit as x approaches a from the right of f of x. This was our definition of limit, and I kept telling you guys this. The limit from below equals the limit from above. Now remember, the idea behind a limit is you're getting very, very close to this number, but you're not actually this number. So if this number is 4, and you want to go from the left, you're going to get like 3.9, 3.99, 3.999, 3.9999999. You're going to get very, very close to 4, but you're not going to be 4, and we're going to see what's going on with the function. And if you're taking the limit as x approaches a from the right, that's from the bigger side of 4, you're talking about plugging numbers like 4.1, 4.01, 4.001. And if the two numbers that from both sides, if you're going towards the same number, then that number is called the limit. Okay? But that's the idea. Now, in terms of algebra, rules. The first rule of limits is when you're taking the limit as x approaches a of f of x, plug in the number. Okay. Here's the deal. If you don't have a problem, aka divide by 0, taking a square root of a negative number, some a violation of some mathematics rule, when you plug in a number, if you get a number, you're done. Okay? So plug in a number. And if you get a number that is the limit. Let me give you an example. The limit as x approaches 2 of 3x squared plus 1. Look at it. 3x squared plus 1. That guy has no problems. That domain's all real numbers. You can plug anything to this guy you want to. What number we're going to plug in? We're going to plug in 2. So the answer is going to be 3 times 2 squared plus 1. 2 squared is 4 times 3 is 12 plus 1 is 13. The answer is 13. If it has no problems, just plug it in. It's when you have problems. And when do you have problems? Dividing by 0 is going to be our big one. So, case number 2 is this. When I take the limit as x approaches a of f of x, and we plug in the number a, and we get a number divided by 0. So here's the deal. You're not officially allowed to divide by 0. And with our definition of a limit, when I have a number divided by 0, when you do the little one-sided limits on that, it either typically blows up to infinity or blows down to negative infinity. You can get that infinity or negative infinity kind of answer. But here's the definition of limits. For a limit to exist, you have to approach a number. Infinity is not a number, it's an idea. It's the biggest number you can think of plus 1, or negative infinity. The smallest number you can think of minus 1. It's a number you never get to. So it's not an actual number, it's an idea, just getting bigger and bigger and bigger, or smaller and smaller and smaller. So in this the case, when it comes to full limits, and that's what we're talking about here, this idea of full limits, then the answer is DNE. And what does DNE stand for? Does not exist. No solution, if you will. Now, with one-sided limits, you can have an infinity or a negative infinity, but when we're talking about a full limit, so we're in section 2.1a, 2.1b, and 2.1b, we're talking about the full limit. You can't have an infinity answer. Now, I can sit there and do the chart and see if it blows up to infinity or minus infinity. That's fine, and we'll put those kind of answers in. But when it comes to a full limit, you can't have an infinity answer. But the third case is the most important case. Case number 3. When I take the limit as x approaches a of f of x, again, rule, plug in the number. This idea of plugging in the number is what they call substitution in our textbook. And we get, this is important, 0 divided by 0. This is that indeterminate form we were talking about last time. You are supposed to do algebra, and what I mean by do algebra is simplify and factor, and then the goal is to try to cancel, and then redo the limit by plugging in the number again. So just basically 3 cases of limits here. First rule limit, plug in a number. Get a number, you're done. Second rule, plug in a number. If I get a number divided by 0, you're good to go. The answer does not exist. Third case, if I plug in a number and I get 0 divided by 0, that's going to be the trick. I'm going to have to do some kind of algebra. Expand, FOIL, factor, do something or other, and try to cancel, because that 0 over 0, the indeterminate, the goal is hopefully something's going to cancel. Sometimes it does, sometimes it doesn't. I can still get an infinity answer, which does not exist. I can get a 0 over 0, sometimes that cancels. You can get 1 or 45 or whatever number you want. Sometimes in this, as the numerator is 0, sometimes you get a 0 answer. So you get different kind of options, but after you get to figure out what's going on, you actually have to do algebra on this one. This is my quote is do algebra, simplify, factor. The goal is to cancel something. So, come back over here to our notes. And we were in the practice problems here. We did the one on the video. So let's pick up the practice problem here. Take a look at this guy right here. This is a full limit. It says take the limit as x approaches 3 of 3 minus 13x plus 4x squared divided by x minus 3. First rule limits, what we're going to do. Plug it in. And now, the other thing you're learning also is proper etiquette of mathematics. Proper etiquette of mathematics is look at how I write this stuff up. The object is, yes, to get the right answer, but that's not full credit. You got to get the right answer and write it up properly. When I plug in a number, I don't write limits anymore. So this will be 3 minus 13 times 3 plus 4 times 3 squared over 3 minus 3. It's clearly 0 in the denominator here, but the numerator, I'm going to get 3 minus 13 times 3 is 39, plus 3 squared is 9, times 4 is 36. 3 minus 39 is negative 36, plus 36 is 0 over 0. What a surprise. Now with 0 over 0, what am I going to do? I'm going to do algebra. First thing I'm going to do is clean them up. Look at this numerator. 3 minus 13x plus 4x squared. That's a classic quadratic, but I like running quadratics in decreasing order. It's proper etiquette here. So I'm going to rewrite this guy as 4x squared minus 13x plus 3 over x minus 3. And then I'd look to see if I can factor something out. Notice proper etiquette. While I'm doing algebra on this function, I keep writing the word limit in front of it. Limit as x approaches 3. Limit as x approaches. I'll keep writing limit up until the point where I plug in the number. When I plug in the number, I don't write limit anymore. Proper etiquette of mathematics. So this denominator is pretty much just x minus 3, but how is this numerator going to factor? 4x squared minus 13x plus 3. Well, 4x squared can factor into 4x times x or 2x times 2x, and the 3 can only factor one way, 1 times 3. So basically I'm doing this anti-foil thing here. But here's the deal. Because the 3 has a plus on it, I'm going to have to, when I on my FOIL, I'm going to have to add up to get the middle term of 13. So, if I do 2, 2 times 1 is 2, 2 times 3 is 6, 6 and 2 is 8. My middle term is not 8, so that's not my option, is the 2 and the 2x and 2x. I'm going to try 4x and x, and since the middle number is kind of big, I'm going to see if I can get a big thing out of this. If I multiply the 4x times 3, what do I get? 12x, and the x times 1, I get x, and 12x plus x is 13x. That's the way I got to go. So I got to do 4x times the x, and now I got to do the 1 and the 3, but I want to make sure I multiply the 4x times the 3, so am I foiling it? I'll go there, and the x times 1. Now I got to just figure out the signs. Because it's a plus, they have the same sign. Last term's a plus, they have the same sign. The middle term's a minus, so the middle term as being a minus means the same sign, they're both going to have to be minuses. So they can add up to be, quote, negative 13. And you can pull it back out to double check. But here's the other clue. Remember I told you 0 or 0, the goal is to get something to cancel. I kind of knew what one of the factors had to be because the goal is to get something to cancel. The only thing in the denominator is x minus 3, so that's the dude that should cancel. So they're going to cancel. So this would be equal to, rewrite it, the limit as x approaches 3 of what's left, 4x minus 1. This is your resultant. Now, take the limit. Again, plug in the limit, plug in the number. This would be 4 times 3 minus 1, 12 minus 1, and the answer is 11. Does that make sense? Questions? Take a look at the next guy. Again, don't just say the answer is 11 and try to get 11, but it's not just about getting 11, it's about how I wrote it up. When I plug in a number, I'm checking it out, and then I decided 0 over 0, so I want to do my algebra case, so I rewrite limit, clean it up, rewrite limit, factor it, rewrite limit after I cancel, and then plug in the number again, and then circle my answer. So it's not just about getting the right answer, but about how you write up getting this right answer. Look at the next one. Take the limit as x approaches 7 of x plus minus 7 over x squared minus 49. First rule of limits is plug it in. 7 minus 7 over 7 squared minus 49. 7 minus 7 is 0. 7 squared is 49 minus 49 is 0. Yep, one of these classic 0 divided by 0 cases. So this will be equal to the limit as x approaches 7 of, and I'm going to do algebra. Now x minus 7, there's not much I can factor out of that guy, so I'm going to leave him alone. But x squared minus 49, that is a very special type of quadratic. It is called a difference of squares. And how does a difference of squares factor in the case of x squared minus 49? It factors into x minus 7 times x plus 7. It's the same thing. 7 times 7 is 49, but opposite signs. One's a negative, one's a positive. Now, cancel. What cancels? The x minus 7s. And when everybody cancels, what are you left with? Careful. What are you left with in the numerator? 1. When everybody cancels, you always have a 1 up there, and then the x plus 7 in the denominator. And now, once you clean them up, now you plug in the number again, so it's 1 over 7 plus 7, and the answer is 1/14. Does that make sense? Notice how I wrote it up. But there's some more examples, so let's take a look at the next one. So here's one that you're going to see in your near future in terms of applications, but here's the problem. We're supposed to take the limit as h approaches 0 of f of 3 plus h minus f of 3 divided by h, where f of x is equal to x squared minus 2. Well, first thing you want to do is actually crunch this guy out. So this is the limit as h approaches 0 of, now, f of x is x squared minus 2. We need to find what f of 3 plus h is. So here comes that functional notation. If f of x is x squared minus 2, what is f of 3 plus h? I don't care what's inside that parentheses, I'm going to replace the x in the original problem with that. I've got a 3 plus h. So this will turn into 3 plus h squared minus 2. Does that make sense? And the other thing I need for this problem is what f of 3 is. A little colon there, and let's calculate f of 3. Now, 3 is inside the parentheses, so I'm going to replace the x with 3. This will be equal to 3 squared minus 2. This is nothing but a number. 3 squared is 9 minus 2 is 7. So here we go. F of 3 plus h is actually, I'll put little parentheses around it. This would be 3 plus h squared minus 2, close parentheses there, minus f of 3, which is 7, close parentheses there. There's my numerator, divided by h is my denominator. And I just want you to literally see I'm just replacing f of 3 plus h with its functional equivalent, and f of 3 I'm replacing with 7. Now, I want to clean this guy up. What does 3 plus h squared mean? And this is where most students are going to screw this up. They're going to tell me 3 plus h is 9 plus h squared. Clearly, you can distribute the 2. No, it doesn't work like that. The pluses and minuses, you're going to have to, squared means multiply by himself. So this will be equal to the limit as h approaches 0 of 3 plus h times 3 plus h. And then minus 2, minus 7, just cleaning up some parentheses there, all over h. Now to clean this guy up, you actually have to full it out. Otherwise, you won't get the right answer. So this will be equal to the limit as h approaches 0 of 3 times 3 is 9, 3 times h is 3h, h times 3 is another 3h, and h times h is plus h squared. That's me pulling this thing out. And go ahead and combine like terms here. What's minus 2 minus 7? Minus 9 all over h. And I did combine those two guys together with minus 9. Now, clean it up. So this is equal to, and I keep writing limit until I actually plug in the number, h is going to 0. Here, the 9's cancel. 9 minus 9 goes away. The 3h plus 3h is what? What's 3h plus 3h? 6h. So this will be 6h plus h squared divided by h. Remember your algebra. The ultimate goal on any 0 over 0 problem is to cancel out something in the denominator. I got to cancel. In this case, there's only one thing in the denominator, h. You can only cancel through strict multiplication division. Don't just sit there and knock out these h's, because that's a violation of 45 years of mathematics here. Wrong. It's got a plus in the middle of it. You can only cancel through strict multiplication division. So, I need to be able to multiply. Multiply and divide means I need to factor stuff out. Look at your numerator. What do you have in common? 6h plus h squared. What do you got in common? H. So this would be equal to the limit as h approaches 0 of h times, when you factor out the h, you're left with 6 plus h divided by h, and the h's cancel. That's the way it cancels, through strict multiplication division. And then this would be equal to the limit as h approaches 0 of 6 plus h. So you finally cleaned them up and canceled your denominator. The last thing you're going to do is plug in the number. H is 0, so you get 6 plus 0. And notice I don't write limit anymore once I plug it in. And the answer is 6. Does that make sense? All right. Now, remember this. When you're doing limits, and I'm doing a full limit on something like a piecewise function or something like that, For a full limit to exist, the limit from below has got to equal the limit from above. They've got to go to the same number, and then that number is the full limit. If the limit from below goes down here to like 14, limit from above comes up here to 27, what is the full limit equal to? They're not going to the same thing, so we say the limit does not exist. So on this particular problem, when you're doing a piecewise function, so I've given you guys f of x is equal to 3x plus 1 if 0 is less than or equal to x, which is less than or equal to 4. X squared minus 3 if x is greater than 4. You're supposed to find the limit as x approaches 4. Now we got a little minus sign, so this is back to the last chapter from the left side of f of x. And the limit as x approaches 4 from the right side of f of x. And then we got to figure out what the limit approaches 4 of f of x is. So here we go. So when we're going to take the limit as x approaches 4 from the minus or from the left side, that means we're plugging in numbers slightly less than 4. When you got a piecewise function, you got to figure out which piece you're going to plug into. Since we're slightly less than 4, and 4 is my breaking point here, if we're less than 4, in this case, we're going to plug it into the function 3x plus 1, because that's, you get plugged between 0 and 4. Up to 4, you get to plug in this guy, including 4, granted, but we're plugging numbers slightly less than 4. Now, how do I do a limit here? Limit, still first rule limits. What are you going to do? Plug it in. I'm not doing, notice, I'm not doing a t-bar. The t-bar stuff is the only time when I get divided by 0 and I'm going from one side, number divided by 0 if I want to go to infinity or negative infinity. I'm going to do a t-bar. So plug it in. This will be 3 times 4 plus 1. That's 12 plus 1. That is 13. Does that make sense? Now, take the limit as x approaches 4 from the right side of f of x. So this would be equal to the limit as x approaches 4 from the right side. From the right side means I'm plugging in numbers slightly bigger than 4. If I'm bigger than 4, which piece of my piecewise function do I use? I'm going to use the bottom one, the x squared minus 3, because I'm told that I can only plug in numbers greater than 4 into this guy, and that's what I got, 4 from the plus side. Once again, first rule of limits is plug it in. So this is equal to, plug it in, that'll be 4 squared minus 3. 4 squared is 16 minus 3. And what's 16 minus 3? 13. Now, what is the limit as x approaches 4 of f of x? The answer is 13. And the reason for that is the limit from below is going to 13. The limit from above is going to 13. They're going to the same number, and therefore that full limit will be 13. Just to show you an example. If I did this, f of x is equal to this piecewise function, 2x plus 1 if x is less than negative 2, and x squared plus 5 if x is greater than or equal to negative 2. And I ask you, what is the limit as x approaches negative 2 from below of f of x, and the limit as x approaches negative 2 from the right of f of x, and what is the limit as x approaches negative 2 of f of x? Okay, so I'm going to blow this up so you guys can see this over here. So now, I'm taking limit as x approaches negative 2 from below. It means I'm slightly less than negative 2. I'm going to plug it in the function 2x plus 1. Plugging it in, I get 2 times negative 2 plus 1. 2 times negative 2 is negative 4 plus 1 is negative 3. When I take the limit as x approaches negative 2 from the right, that'll be the limit as x approaches negative 2 from the right of. That means I'm slightly bigger than negative 2. I'm going to plug it into x squared plus 5. That'll be negative 2 squared plus 5. Negative 2 squared is 4. Plus 5 is 9. So I now ask you, what is the limit as x approaches negative 2 of f of x? Does not exist. Why is this answer does not exist? Because the limit from the below, from negative 2 from below is negative 3. The limit as x approaches negative 2 from the right is 9. They're not going to the same number. And when they don't go to the same number, that means that full limit, without that little plus or minus behind it, is going to be does not exist. When you get the same number, that limit is that number. But if they go to two different numbers, the full limit answer will be does not exist. That's the main idea here. Does that make sense? Yeah.
With C, do we need to just write routine in
Yep.
that exam?
Yep.
Or do we need to prove mathematical?
No, well, the piecewise function, you're proving it mathematically by doing the one side left, one side right. If it was a nice, not a piecewise function, but a nicer function, if you want to call that one the nicer function, or better yet, maybe a function like this first one that we did up here, okay, or this one over here that we did, that without the piecewise function, this is the algebra I expect to see to actually show your answer. But with the piecewise functions and those one side, the only way to show a full limit on a piecewise function is show the limit from both sides and make sure you go to the same number, and that's what's going to be that way. All right, section 2.2a. Section 2.2a is about the average rate of change. All right, so let me go grab myself another nice little sheet of paper here. All right, this is the idea behind this average rate of change. What we're going to be looking at is some kind of interesting function. I don't care what the function is, it looks something like this, who cares? Here's f of x right there. And we're going to be picking out a couple of interesting points. We're going to pick out, for example, this interesting point right here, x1. I'm going to plot him. And I'm going to pick out another interesting point, x2, and I'm going to plot him. When I plot them, they have y-coordinates. The y-coordinate down here is going to be f of -1. Here's your y-axis here. Here's your x-axis. When I plot x2, here is the f of x2. The quote, average rate of change, this average rate of change between these 2 points is basically the slope of the line that literally connects these two dots. It's the slope of that particular line that connects those 2 points that I picked arbitrarily. Does that make sense? This x1 and this x2. So you remember this average rate of change is equal to the slope of the line connecting x1 and x2. This is the idea. Now, what was that formula for slope of a line? You remember? Slope, the symbol is typically m. What was my formula? It was y2 minus y1 over x2 minus x1. You may also remember this as, what does that little delta stand for? Change in y over the change in x. But the y2 coordinate, we're going to call it, because we're using this function, it's going to be f of x2. The y1 coordinate is f of x1 over x2 minus x1. And this is the formula they traditionally refer to when it comes to the concept of average rate of change. So this average rate of change formula is equal to f of x2 minus f of x1 over x2 minus x1. Now, the line that connects 2 points on a function, 2 different points on a function, this is called the secant line. Don't be thrown off by that trigonometric concept of secant line. It's just a name. It's called a secant line, a line that connects 2 points on any arbitrary function that I give you guys. Just pick a point x1 here, pick a point x2 here, 14, -37, whatever. Find the line that connects those 2 dots on that function. That line is called a secant line. Okay? Now, so here we go. These are the main ideas. So let's go through the course again. Hopefully you watched the little learn mode on Hawks and watched the little video they have embedded in there where they're talking about these concepts. and as well as watch the PowerPoint presentation on this stuff, okay? Go to the Hawks TV to actually get a actual real example of the work on this stuff, and we'll do that in a second, but here we go. Okay. Now, to set you guys up, it says, all quantities met in everyday life change with time. This especially is true in the science field. Chemists may be interested in the rate at which a substance dissolves in water. A biologist may want to know how the bacteria in a culture is changing with time. These lessons will introduce this concept of average rate of change of some kind of function f of x with respect to x as x changes from one value to another. And then basically what we're talking about here is this concept of slope, rate of change in y over the change in x. Okay, so here we go. The Greek letter delta is used in calculus to indicate what? What would we call that delta? Change. The change in x can be written as delta x, and the change in y is written as delta y. Now, for a function y equals f of x, the values that change from x1 to x2 that correspond to the value that change from, the value of y that change from, and this would be y1 to y2, but since we're dealing with a function here, y1 is also known as f of x1 to f of x2. And here it is. If y equals f of x, then the ratio of change in y over change in x, which is y2 minus y1 over x2 minus x1, equals f of x2 minus f of x1 over x2 minus x1. Another math formula for this class is called the average rate of change of y with respect to x as x changes from x1 to x2. Okay? So, here comes my Hawks TV video example. Remember, this is not the exact same example that's on the Hawks TV. They do one similar, but from watching that, you should be able to do this one. All right. So, given f of x equals 3x squared minus 2x minus 1, find the average rate of change. So, that's what we're looking for. Average rate of change, which is a formula. F of x2 minus f of x1 over x2 minus x1, as x1 equals 1 and x2 equals 1.5. So officially this would be f of x2, which is 1.5, minus f of x1, which is 1, over 1.5 minus 1. Now, f of x was given to be 3x squared minus 2x minus 1. What is f of 1.5 going to be? That'll be 3 times 1.5 squared minus 2 times 1.5 minus 1. Well, time for the old handy dandy calculator now. So I'm going to slide this up so you guys can see my calculator. 3 times 1.5 squared minus 2 times 1.5 minus 1. And I get 2.75. Does that make sense? Now, the other number I need is going to be f of 1. I don't think I need a calculator for that. Let's see here. This would be 3 times 1 squared minus 2 times 1 minus 1. 1 squared is 1 times 3 is 3. 2 times 1 is 2. 3 minus 2 is 1. Minus 1 is 0. I can put it on a calculator if I need to, but I don't think I need to do it on that one. So now, here we go. What was f of 1.5? It was 2.75 minus f of 1 at 0 divided by 1.5 minus 1. Well, 2.75 minus 0, that's easy math, that's 2.75. 1.5 minus 1 is 0.5. And so, the answer is 2.75 divided by 0.5 equals 5.5. That is the average rate of change. And when you look at this average rate of change, typically you're going to have units. This is your functional value. Let's say we're doing that biology problem. The function is based upon number of bacteria. So this will be bacteria minus bacteria, which is a difference of bacteria. and over time. X2 is time, X1 is time. Time minus time is time. So this would be number of bacteria over seconds, let's say, or minutes or hours or something like that. So you get bacterias over hours, and we would call that bacteria per hour. This idea of per, you're going to see within these units on rates of change. Bacteria per hour. You can also, this can be distance, change in distance over change in time. This would create some kind of a velocity type situation. Feet per second, miles per hour, kilometers per hour, meters per second, something like that. So here we go. Find the average rate of change of f of x as x changes from x1 to x2. So again, knowing my formula, average rate of change. This problem, f of x is equal to 5x plus 3. x1 is 1.5, x2 is 3. So this would be f of x2, which is 3, minus f of x1, which is 1.5, divided by 3 minus 1.5. Again, just to remind you, and so I don't have to write the formula down so many times, the average rate of change formula that you would expect you guys to have memorized is equal to f of x2 minus f of x1 over x2 minus x1. Now, plugging this stuff in this problem, f of 3 would be equal to 5 times 3 plus 3. 5 times 3 is 15, plus 3 is 18, so this is equal to 18 minus f of 1.5 will be 5 times 1.5 plus 3. I'll do that one on the old calculator here. 5 times 1.5 plus 3 is 10.5. So here we go. This will be f of 3, which is 18, minus f of 1.5, which is 10.5, divided by 3 minus 1.5. 18 minus 10.5. 18 minus 10.5 is 7.5, divided by 3.3 minus 1.5 is 1.5. So the answer is going to be 7.5 divided by 1.5, which is the average rate of change between x1 equals 1.5 and x2 equals 3 is actually 5. Okay? Number 2, find the average rate of change of 2x, f of x equals 2x squared minus x minus 3. x1 equals 2.1 and x2 equals 2.5. So again, using my formula, average rate of change, this would be equal to f of 2.5 minus f of 2.1 over 2.5 minus 2.1. F of 2.5 will be 2 times 2.5 minus 2.5 minus 3. Again, time calculator, sliding it up. 2 times 2.5 squared minus 2.5 minus 3 is 7. F of 2.1 would be 2 times 2.1 squared minus 2.1 minus 3. And I'm going to use the second entry button on mine. The second entry calls back down the last thing you typed in, because all I'm really doing here is changing all these 2.5s to 2.1s. 2 times 2.1 squared minus 2.1 is 3.72. So this average rate of change will be f of 2.5, which is 7, minus f of 2.1, which is 3.72, divided by 2.5 minus 2.1. So now I'm going to work the numerator. 7 minus 3.72 is 3.28, divided by 2.5 minus 2.1 is 0.4. And so when I divide this, I end up getting 3.28 divided by 0.4 is 8.2. Does that make sense? And what we're doing is really we're finding the slope between these 2 points. Well, let's try this one here. f of x equals negative 2 divided by 2x minus 1. x1 is 1, x2 is 3. So, average rate of change is equal to f of x2, which is 3, minus f of x1, which is 1, over x2, which is 3, minus x1, which is 1. f of 3 minus f of 1 over 3 minus 1. Now, f of 3, that would be negative 2 over 2 times 3 minus 1. It'll be negative 2 over 2 times 3 is 6, minus 1 is 5. So this is going to be negative 2/5. Minus f of 1, that'll be negative 2 over 2 times 1 minus 1. Let's see here. 2 times 1 is 2, minus 1 is 1. Negative 2 divided by 1 is negative 2. Watch your signs is why I'm putting these parentheses around this. So I got negative 2/5 minus negative 2 divided by 3 minus 1. So, going for the calculator on this one. Negative 2/5. A minus makes it plus 2 is 1.6 divided by 3 minus 1 is 2. And 1.6 divided by 2 is 0.8 or 0.8, however you want to write that out. And the last one is this one. f of x is equal to the square root of x minus 3. x1 is 4, x2 is 4.44. So again, calculating the average rate of change. This would be f of x2, which is 4.44, minus f of x1, which is 4, over 4.44 x2 minus x1, which is 4. So, what is f of 4.44? That'll be the square root of 4.44 minus 3. And that's like 1.2 or something or other, because 4.44 minus 3 is 1.44. And so when we take the square root of 1.44, and I'll just type it in like this. 4.44 minus 3, which is 12.44, and 144 is like the square root of 12. Square root of that's 12. So something like a 12 is 1.2 is what I get. And f of 4, I can do that with a calculator. That'll be the square root of 4 minus 3. That's the square root of 1. Square root of 1 is 1. So this would be equal to f of 4.44 is 1.2 minus f of 4 is 1 over 4.44 minus 4. Well, 1.2 minus 1 is 0.2. 4.44 minus 4 is 0.44. Now I'm going to put this on the calculator just to show you what you get here. 0.2 divided by 0.44 is 0.4545454545, How do you typically write a repeating decimal? You remember the symbolism for that? 0.45 with a bar over it. But if you're typing this stuff into the Hawks platform, the Hawks system and stuff like that, you know, this repeating decimal thing, you can type in 0.45454, it'll get it to you. But personally, I'm just going to go ahead and make them to a nice fraction, because repeating decimals will make a nice fraction. And the actual fraction is 5/11. Also take it to 1. There you go. Does that make sense? Now, we're setting you guys up for stuff, this average rate of change stuff, because the next section, which I'll go over next time, but I kind of want to introduce it to you guys, is this idea of instantaneous rate of change. So, and again, I will discuss with you next time, but the idea of the instantaneous rate of change is this. So, I got some kind of function, don't care. Here's old f of x. Here is that x1. Here is x2. And you'll notice that we just found the slope of the line that literally connects these two guys together, right? But if we're going to be focusing on one of these points right here, okay? So here's my function again, and I'm focusing on this particular point right here at x1. So instead of making x2 way out here, why don't we bring it in a little bit, x2. And so instead of being so far away, we're going to bring in our points a little bit closer. And we can still find the instantaneous rate of change between those 2 points. But let's make it even closer. And right next to it is x2. So when we actually talk about the 2 points being literally on top of each other, what we're doing here is, see, this is your delta x. This is your delta x. Now look at your delta x. What's happening to delta x? The delta x's are getting what? The distance between the 2 points are getting smaller. We're actually taking the limit as that delta x is approaching 0. And when you do, remember I taught you guys last time that this is called the secant line? You guys know it when you just have a line that just touches one point on the graph and then moves off in the direction of that graph? That is called the tangent line. Tangent line of f of x at the point x1. And that slope is what we're going to be going after. So remember you had that f of x plus delta x minus f of x over delta x. You're going to take the limit as that delta x, that change, approaches 0. That's going to give you that slope of the tangent line. This is going to be that instantaneous rate of change. So instead of trying to figure out what's happening between these 2 points, you're going to figure out what's happening exactly at that particular point, the change at that particular point, the rate of change at that particular point. This is what section 2.1b is going, 2.2b is going to be all about. And we'll talk more about this next time, but I'm just trying to set you guys up for it. So study hard and don't forget it. What's that?
What's the application for that?
The derivative. That's what we're going for. It's going to be something called the derivative.